In this lecture, we will learn about what lists are and how to work with them in Python. What is a list? Put simply, a list is an ordered collection of data. If you are familiar with other programming languages, lists are the Python equivalent of arrays. Let's take a look at a basic example first. We will create a variable named collection and set it equal to a list with the elements 1, 2, and 3. If we want to see how many elements are currently in our list, we can use the len function. For example, we will call the len function on our collection list and print it to the console. Let's say we want to grab one of the values out of the list. To keep it simple, let's try to grab the first element from our list, the 1. We can do this by what is called indexing. In programming, ordered collections like lists have a concept called indexing, meaning that each of their elements is stored at a specific, numbered position in the collection. Indexing starts at 0. In our list, we would say element 1 is at index 0, element 2 is at index 1, and element 3 is at index 2. When we want to get an element at a certain index, we first type the name of the list, which is collection in this case. Then we use square brackets, inside of which go the index of the element we want to access. For example, we want to access the element at index 0. When we run the code, you will notice that 1 was printed to the console. If we change the index to 1 and run the code, you will notice that 2 was printed to the console. And by that same logic, changing the index to index 2 and running the code will result in 3 being printed to the console. One common mistake of beginner programmers is that they forget that indexing starts at 0, and they end up using index 1 to try to reference the first element in the list. There is another way to reference elements, and that is by using negative indexing. Negative indexing starts at the end of the list and begins at index -1. For example, we can print out collection at -1, and we will see that 3 was output to the console. If we want to access the 2 in our list, then we could do so using index -2. If we change the index we are referencing to -2 and then run the code, you will notice that 2 is output. By now I think you get the idea. Obviously we could access element 1 with index -3, but I won't bore you with that example. We can also use a range of indices when working with lists. For example, let's say we want to grab the first 2 elements in our list. The way that we do that is as follows. We start out with the name of the list and square brackets, just like before. Then comes the starting index. We want to start out with index 0. After that comes a colon, then the end index, which is exclusive. This means that the sublist we get will include the elements up to 1 less than this index. So since we want to just grab the elements 1 and 2, we specify the index 2, since the program will then grab the elements at indices 0 and 1, but not 2. Remember, the ending value is exclusive, not inclusive. We can also choose not to specify a start or end value in this scenario. If we don't specify a starting value, then it will automatically start at the beginning of our list. For example, removing the starting value of 0 will have the same effect as our current code. When we run the code, notice that the sublist output to the console contains the elements 1 and 2. We can also omit the end value, which means that the sublist will go to the end of the list. For example, removing the 2 and running the code will result in the whole list being output as the sublist we grabbed using this technique. What if we want to change the value of an item in the list? We can do so using its index. For example, let's say we wanted to change the value 3 in our list to 4. First, we will reference collection at index 2, which is the position of the value 3 in the list, and then we will use the equal sign to set it to 4. Next, we will print out the value of collection at index 2. When we run the code, you will notice that 4 was printed, meaning our code worked. Let's learn how to loop through all of the items in a list. We call this iterating over the items in a list. To accomplish this, we can use a for loop. The first step is to type for I in range, and then pass in the len function, and then the collection. This tells Python to create a variable I, known as an iterator variable, and then to execute the for loop, the amount of times of elements in the collection. On each iteration, I will change its value to be the element in the collection that it is currently on. Inside of the for loop, we will print out collection at index I. When we run the code, you will notice that the values 1, 2, and 3 were printed out. On the first iteration of the for loop, we start at the beginning of our list. The first item in our list is 1, so I becomes 1, and then we print out 1 to the console. Then the second iteration happens. The second list item is 2, so 2 gets printed out to the console. Finally comes the third iteration. On that iteration, the value of I is 3, so 3 is printed to the console. What if we wanted to check if an item is in the list? How would we go about doing that? We could combine the concepts of an if statement and Python's in keyword to achieve the desired effect. We start out with an if statement and say if 1 in collection. This will check if the element 1 is present in our collection. If this is true, we will print the phrase 1 is in the list to the console. Else, we will print the phrase 1 is not in the list to the console. When we run the code, you will notice that the if statement evaluated to true because 1 is in the list, and the phrase 1 is in the list was output to the console. Now that we have a general understanding of how to work with lists in Python, let's learn about the different functions we can use on lists. If we want to add an element to the end of the list, we can use the append function. For example, let's use Python's append function to add the element 4 to the end of our list. Then we will use Python's print function to print our list to the console. To remove all of the elements in a list, we can use the clear function. We will use the clear function on our collection list and then print out collection to the console. When we run the code, you will notice that our list is now empty. Let's actually intentionally put the list elements out of order for this next example. We will make the order of the elements 2, 3, and 1. To sort the elements of a list in Python, we can use the sort function. For example, let's call the sort function on our list and then print it to the console. When we run the code, you will notice that the list was sorted. To reverse a list, we can use Python's reverse function. When we run the code, you will notice that the list was printed with the elements in reverse order. Let's say that we want to count how many times the element 2 appears in the list. To do this, we can use Python's count function. We will print out the result of a call to collection.count and pass in 2. When we run the code, you will notice that 1 was printed to the console. This makes sense since there is one instance of the element 2 in the list. We can combine two lists by using the extend function. First, we will create another list named collection2 and assign it a list with the values 4, 5, and 6. Then we can combine the two lists by doing collection.extend and then passing in collection2 inside of the parentheses. Then we will print out collection to the console. When we run the code, you will notice that collection not only contains its original elements, but also contains all of the elements from collection2. We already looked at how we can retrieve an element by its index, but what if we wanted to retrieve the index of an element? To do this, we can use Python's index function. For example, we can find the index of the item 2 in the list by calling the item function on our collection list and passing in 2. When we run the code, you will notice that 1 was printed since the index of element 2 in our collection list is 1. To insert an item into our list, we can make use of Python's insert function. For example, if we want to insert the element 9 into our list at index 0, we will call collection.insert and pass in 0 as the first argument and 9 as the second argument. Let's also print the collection to the console. When we run the code, you will notice that 9 was added as the first element of our list, thanks to the insert function. Now we know how to add items into a list, but what happens if we want to remove items? To do this, we can use Python's pop and remove functions. If we want to remove an item at a certain index, we can use the pop function. For example, we can pop the element at index 0. When we run the code, you will notice that the first element was removed from the list. Python's remove function allows us to remove an element from a list by its value. For example, if we want to remove the element 1 from our list, we can use the remove function and pass in 1. When we run the code, you will notice that the element 1 is no longer in our list. It is important to take note that you can have items of different types in Python lists. It is perfectly valid for us to have a list that contains a string, integer, bool, or even another list. Lists are one of the most important and most used collections in Python. In the next lecture, we will learn what tuples are and how to work with them in Python.